Let's discuss the characteristics of contour lines and the methods of analysis of these contour lines in the third part. We have already learned the details of contour lines in our previous classes. Contours are imaginary lines drawn on maps connecting those places having equal elevation from the sea level. Let's repeat. Contours are imaginary lines drawn on maps connecting those places having equal elevation from the sea level. A contour line joins points of equal elevation above a given level, such as mean sea level. The respective altitudes will be marked with each contour line. Look at the map given there and find out the contour lines. In the figure, we can easily find out the altitudes that marked with each contour line. These altitudes are generally known as contour values. Look at the next figure given there and read the contour values 100, 200, 300, 400, 600, 500, etc. And this difference between the value of the two adjacent contours is called contour interval. And in the given figure, the contour interval is 100. The difference between adjacent contours, for example, 800 minus 700 is 100, or 700 minus 600 is 100. So the contour interval in the given figure is 100. So the difference between the value of the two adjacent contours is called contour interval. Let's analyze the next characteristic of contour lines. You might have noticed that in the given picture, the contours are closely spaced at certain places and are farther apart elsewhere. Look at the picture again. In the location A, the contour lines are farther when we compare with the location B, where the contour lines are nearer. The closely spaced contours represent steep slopes and the widely spaced contours represent gentle slopes. Let's find the characteristic of these contour lines again. The closely spaced contours represent steep slopes, which means in the location B, there is steep slope and in the B there is a gentle slope. It is very important to get the details of a topography by assessing these contour lines. These are the three things to be assessed. One, altitude of the place. Second, nature of the slope. Nature of the slope means whether it is steep slope or gentle, then shape of the landform. It is very clear that the shape of the landforms are determined by using these contour lines. How can we determine the shape of these landforms? There are two important methods. One, that is the first method, directly from the contours. Look at the screen. There is a figure that shows some contour lines While using this method, let's place a paper strip across the contour pattern which the topography is to be assessed. Look at the picture again. Then mark A and B at either sides of the paper strip. Mark and label the values of the contour lines, which means 500, 600, 700, etc., cutting across the paper strip. Then turn to the next figure. Transfer these contour values, which means this paper strip, onto the x-axis of a graph paper. Choose a convenient scale and mark the contour values on the y-axis. Contour values 500, 600, 700 must be added on the y-axis. Then look at the next picture. Draw vertical lines from the points of contour values on the x-axis. Intersect these vertical lines against the corresponding values in y-axis and mark the intersecting points. Join these points by smooth curves. And look at the screen again. Shade the area, that is the blue colored area, using a pencil when we draw it in your notebook. Thus we get to the shape of the landform represented by the contour values. This is the first method. Then second method, by tracing out the contour lines. Look at the figure again. Copy the contour lines on a tracing paper and transfer them onto another paper. Which means copy these contour lines on a tracing paper and transfer it to your notebook. Draw a line AB. Look at the picture. Draw a line AB through the center of the contours. Then look at the next figure. Draw the x and y axis below the line as shown in the given figure. Mark the values of the contours on both the y axis in an appropriate scale. Draw vertical lines from the points where contours cut across AB. Mark the points at which these vertical lines intersect the horizontal lines. Look at the figure again. Join the points with smooth curves and shade the area using a pencil. That is the blue colored area given there. Thus we get the shape of the landform represented by the contours. For getting more details, you must read your textbook twice or thrice. That's better for getting the details. This is a worksheet for you, and draw the shape of landform in your notebook by using these two contours. Now you are watching the row of electric posts, mobile towers and wireless transmission towers. For erecting these posts, analysis of contour lines is needed. In this situation, the intervisibility analysis of contour lines are very helpful. As part of topographical map interpretation, there arises a need to find out whether two places are intervisible. This can be solved only by finding out the relief as well as the slope of the region. If any two places are mutually visible, then we can establish that these places are intervisible. Let me again, if any two places are mutually visible, these places are termed as intervisible, and it is very helpful for, we have already pointed out that erecting electric posts, mobile towers, wireless transmission towers, etc. Watch the screen. You can see the points marked as P, Q, R, S between the contours. We are going to identify the points which are intervisible or not. Turn to the next picture. For assessing the intervisibility, the shape of the terrain must be inferred from the contour lines. By using first or second method, you can draw the shape of the landscape in your notebook. This is the shape of the landform inferred from the contour lines. By analyzing this picture, we can assess the intervisibility between the places. Look at the picture again. The intervisibility is not possible between P and Q, P and R, and Q and R. Then what is the reason? Because the straight line between this P and Q, P and R, and Q and R goes through the shaded part. When the straight line between these 2 points went through the shaded portion, there may not be intervisibility. But look at the next points, this R and S. There is intervisibility because the straight line between the Q and R goes out of the shaded area. This is the method to find out intervisibility. This is another worksheet for you. Read the question carefully and write down the answers in your notebook.